Yeah. So, how many of you are clear about Leach algorithm, which is discussed in the morning? Yeah. So, how many of you are clear about the algorithm which we have discussed in the morning? So, the Leach, which is the best example of hierarchical and adaptive, right? Low energy adaptive clustering hierarchy. So it is an hierarchical clustering algorithm, right? So then there are two phases in the Leach. What are the two phases? Right? There are two phases. The first thing is yeah. So the two phases are the setup phase, setup and study, right? So during the setup, right, the network gets ready for the study phase where it is applied, right? The sensors are ready for sensing job, right? So first of all, how the setup is done, right? So the setup phase, right? First thing is the node decides whether it wants to be a cluster head or not. If yes, suppose it has been decided as cluster head. First thing is it expresses its willingness to join the cluster. Initially, when clusters are being created, each node decides whether or not to join or not to become a cluster head for the current round, right? So this decision is made based on the suggested percentage of cluster heads for the network, that which is determined a priori. That is, in the formula we see this P. So the P, right, this P is the desired percentage of cluster heads. For example, 5%, right? So 0.05, right? So based on that, this decision is made, and the number of times each node has been a cluster head so far. Please remember. Let me take a simple example to make the intuition behind the formula clear to you. For example, in your class there are let us say there are 20 students. Let us say there are 20 students, because your strength is actually 85, around 85, and calculations with 85 is bit tough. That's why I'm just taking. I'm taking, let us take 100, which is number is good, right? So in this node, let us say the number of nodes, the percentage of nodes that are willing to become cluster heads are 5%, which is P, small p, that is equal to 0.05. 5% is 5 by 100. So what it means, first round, among 100 nodes, 5 nodes are elected as cluster heads. Okay, let us say round 1 is over. Then next round, how many nodes are competing for the cluster head? Here, the nodes which are not considered for the headship are only to be considered. That is, they are only 95. Right? So among 95, again 5% are to be made cluster heads. Now only 90 nodes are left for headship. So like this, every time 5 nodes are made cluster heads. So how many rounds are required for every sensor node to become the cluster heads? Anyone, please? How many rounds? In each round, 5 nodes are made cluster heads, and the nodes which are already cluster heads will not be considered again. So for each and every sensor node to get its turn, how many rounds are required? Anyone, please?
20, sir. 20 rounds.
20 into 5, that is 100. All the nodes will get their turn. How do you get this 20? That is nothing but the reciprocal of P, 1 by 20%. So 100 by 20, that is 1 by P, small p, that is the reciprocal, that gives the number of rounds. So 1 by P is 5%, right? So that is eventually it becomes 100 by 5. So that becomes 20. So in 20 rounds, all the nodes will be rotated with headship, right? After 20 rounds, again, the nodes may be considered for the second time for the headship. That is the idea, right? So here, so P by the percentage of cluster heads, that is 5%, example 5%, that is divided by 1 minus P into R mod reciprocal of P. This is mod operation, right? So reciprocal of P, that is, if it is 5%, it is 20. And round, first round, round 1 mod 20, that is 1. So, right, first round. And that is multiplied with P. So 0.05. So that is to be subtracted. Then that way, the threshold of each and every node is calculated. What is small n here? It is n is referring to the sensor node which is not yet made cluster head, which is not yet become the cluster head. G is the set of nodes. G is a set of nodes that have not been cluster heads in the last 1 by P rounds. In the last 20 rounds, they are not the cluster heads, right? So using this node, every node will calculate, right? Its threshold. Every node will calculate the threshold, and based on the threshold, right? So you just go. Let us go through this. The decision is made by the node n choosing a random number between 0 and 1. If the number is less than the threshold, the node becomes cluster head. Right? So again, another important point is the random function. Remember, random number generators or very good or strong random number generator functions are there, if it is invoked, no, every time it will return a different random number, not the same. So there is the probability that two nodes will get the same random number is very low, is almost zero. So they definitely get different values, right? And it also ensures the uniformity of the random numbers that are generated. So it is the strength of the random number generator plus this formula. With that, no, every time, in every round, 5% of nodes. P is example I have taken only 5%. It can be even 10% or 3%, right? So the formula should be very clear to you. Please understand. Here, T, capital T stands for threshold. Threshold of the node N. What is N here? N, it belongs to the set of nodes which have not been cluster heads. Not been cluster heads in the last 1 by P rounds. So what is P and 1 by P? P specifies the percentage of the nodes that should become cluster heads. And 1 by P gives the number of rounds required for so that each and every node gets the chance to become the cluster head. So if it is 5%, 20 rounds are required for every node. So that is what here 1 by P refers. So with this formula, P by 1 minus P into R mod 1 by P. So with this, each and every node will calculate its threshold, right? And decides whether the random chosen number is right is less than the threshold or not. If the chosen number is less than the threshold, that node becomes cluster head. So in round 1, 100 nodes are there. All the nodes calculate their thresholds. With respect to this, all the nodes have also generated their random numbers, right? They have calculated thresholds and they check whether the random number is less than the threshold or not. Only 5 nodes will be, because P you have selected made as 5%. So only 5 nodes, with respect to that, only 5 nodes will become cluster heads. Right, round 1 is over. And then here remember round 1, what is their first setup phase? Setup is clusters are to be found. Before forming the clusters, cluster heads are to be decided. Among 100, 5 nodes have been identified. Who has identified? On their own, they have identified. It is the adaptation capability. There is no. This is also, you can say, self-organizing capability. Right? There is no central authority to name them. Suppose one node is there, it's a base station, is naming them, you become the cluster head. Such thing is not there. Right? There is no central authority. On their own, they are forming that cluster, they are becoming the clusters. So once the cluster heads are decided, now the next step is they go for advertisement in the same phase. Setup phase only, during setting up, right? They advertise saying that I am the head, right? Any node would like to join me as a member. If so, you can go for registration. So it is what you say, advertisement, cluster head advertisement. So a node, a sensor node is there, it is receiving the advertisement. It may also receive multiple advertisements if it is nearby 2 or more cluster heads, right? So if it is receiving multiple cluster head advertisements for membership, then it can decide the best one. On what basis it can decide the best one? Based on the signal strength. So based on signal strength, right? So it can decide the cluster head to which it is close physically, right? Physically it is close. So that's why it can say reply to that registration. Right, so it is making request for membership, cluster membership. So this is to be repeated by all the nodes, non-cluster head nodes. So once this is completed, clusters have formed. Now that is setup phase is over. Next is study phase. Study means now once the network is ready for the application, depending on the application. So then there can be query diffusion. Base station may issue a query. Now the query is diffused. You can think about your directed diffusion algorithm. Now gradients are established, right? Then best path is chosen. Now data is transmitted. Now round one is over. Let's say the round one, you have fixed the time interval. How the time interval is fixed? Maybe say just to ensure the evenness of battery energy consumption, you may say it is for 10 seconds. So once the 10 seconds is over, whatever it is doing should be hold. And then it comes back to the first phase, setup phase. Setup, what happens again? Cluster head formation, cluster heads are to be identified. That is again the non-cluster head. So far, what are all the nodes? They didn't get the chance for cluster heads. They all are the candidates for the next round. In the next round, only 95 number of nodes are there. Among them, again, 5%. I mean, among them, 5 nodes. Right? Again, they choose their random number. They calculate their threshold. And if the chosen random number is less than the calculated threshold, right, then they become the cluster hits. Again, they go for advertisement. Members, right, based on their proximity, their closeness, they choose their cluster hits. Again, now study phase, setup phase is over. Now study state commences. Again, based on the application, right, the data transmission takes place. Maybe from base station to the sensor nodes or sensor nodes to the base station, depending on the application. So this is the cluster, this is the leech algorithm. The most important thing is you should look at the disadvantages. The disadvantages are, you can easily understand. Is there any rule that the sensor nodes are deployed evenly? Is there any rule that all the cluster heads are scattered uniformly throughout the network? There is no such rule. So the cluster heads which are chosen, they may be very close to each other. Some area they are maybe far away from the nodes. So how communication is taking place from sensor node, member node to the cluster head in turn to the base station. But if all the cluster nodes are very close to base station, cluster heads are very close to the base station, then it is there is no point. The nodes, sensor nodes which are away, farthest from the base station, they are at the disadvantage, right? And so such guarantees are not given by leech. And here the cluster formation is very dynamic, but no parameter is taken into consideration for ensuring the uniformity or the evenness of sensing, evenness of covering of the sensing area. So that is a disadvantage, right? And next time onwards, once the rounds are over, again the nodes are considered for the subsequent headship. So this may cause some disadvantages because there is no uniformity. So to work on this, people have proposed another algorithm, Pegasus, right? So in Pegasus, what is done is power efficient gathering, right? So which is a chain-based protocol, just to eliminate the disadvantages of leech, right? A new protocol has been proposed, so definitely it is an enhancement over leech, right? So from data source to the base station, a chain is formed. like the best route, as in the case of directed diffusion. And how it has become power efficient gathering, other steps are the same. Right? So here in the chain, every time, in order to prolong the lifetime of the network, right, the nodes with their closest neighbors only, right, their nodes will communicate only with closest neighbors, and they take turns in communicating with the base station. So you can take the simple diagram. So diagram I will show you. Yeah, here it is not there. Yeah. Okay. Let us continue. So let us say there is a chain. There is from data source yes or data source yes to the sink or base station B. Right? There are 10 nodes in the chain. So here they will communicate with closest neighbors only, right? But here, to prolong the lifetime, what is to be done? If there are 10 nodes from the data source to the base station, all the 10 nodes, if they are communicating, they are spending their energy. So to eliminate that, right, they are making the turns like node A, the source yes, will communicate with the second node, every alternate node, right? So then that is how they reduce the number of hops. Like earlier it was 10, now it is 5. And next round, some other nodes, the nodes which are left, which are not considered in the previous round, they will take their turns. That way, right, the amount of energy that is required is reduced. Otherwise, all the 10 nodes are participating. Let's say they are taking the energy delta X for every hop. So 10 times delta X is consumed. Now what we are doing, between data source and the base station, there are 10 nodes which are closely placed. Now this chain having 10 is considered as a chain having only 5 nodes. Ignore every alternate node. Start from data source, ignore the next node, and make the next node as active. That way now the chain of 5 will form. Right? Now these 5 nodes will go for data transmission in phase 1. Next round rather. Next round, base station, data source is active. Next neighbor is now made active. And the next neighbor to the neighbor is made inactive. Now again the chain of 5 is formed. These 5 nodes will help in data transmission towards the base station. So that is how it is alternating. There is no hard and fast rule that only alternatively, right? You can consider a group of 3. So first round, second round, third node in the third round, like that. So it all depends how closely they are placed. So that is how the closed nodes are chosen for minimizing the data consumption, energy consumption. So that is how it is named as power efficient gathering. Right? So that is the keyword, power efficient, that is energy efficient gathering. The other thing is just to make to coin a word, right, which is pronunciable, like sensor information systems. It is all right. Just to say Pegasus, they have added sensor information systems, right? So this is, you can understand this. You have any question, please come out. So the power efficient gathering in sensor information systems is a near optimal chain-based protocol, which is an enhancement over leech. Now, can anyone say how leech is working here? Anyone, please? Right. So leech is, so there are only two hops, member to the cluster head to the base station. That is also one disadvantage of the leech. It is always assuming that two hops are necessary, two hops are sufficient for each and every node to reach the base station. Maximum two hops. Right? That is not true. Base station may be far away. With the sensor nodes are spread all across the area, then it is not possible. Within two hops, it may not be able to reach. Right? So we need to have a chain. So the concept that is used in leech is borrowed in Pegasus, and now further enhancement is we are adding near optimal chain based protocol. Right? In order to prolong network lifetime, nodes employing Pegasus communicate with their closest neighbors only, and they take turn in communicating with the base station. I have explained with an example. Right? Whenever a round of nodes communicating with the base station ends, a new round starts. This decreases the power required to transmit data per round as energy dissipation is spread uniformly over all nodes, and as a result, Pegasus has two main goals. First, it aims at increasing the lifetime of each node by using collaborative techniques. As a result, the overall network lifetime is also increased. Second, it only allows coordination between nodes that are close together, thus reducing the bandwidth consumed for communication. To locate, that is, there is collaboration and coordination, right? To locate the closest node, closest sensor node, closest neighbor, sensor nodes use signal strength to measure the distance to all of its neighboring nodes and then adjust the signal strength so that only one node can be heard, right? So that is here we are considering the concept called adjusting the signal strength. Right. So that is one capability. Nowadays, sensor nodes are coming with an ability to increase or decrease their communication range. That is the concept that is exploited by Pegasus. Any question, please? Question, please. Questions are very important. Right? Questions post-lunch session, some of you might be physically present, mentally absent. Some of you are both physically and mentally absent. Just switch on smartphone or laptop or some cases desktop. Right? This is usually happening. Because not even a single question is there. That is, if it is a conventional classroom, I would have looked at your faces and decided whether you are really following or not. But here it is not possible. Right. Next is a very important thing, that is Teen algorithm. It has nothing to do the teen in dictionary, right? Right. Threshold sensitive energy efficient. That is the full form. T for threshold sensitive, W is energy efficient, N is network. Right? So a threshold sensitive energy efficient sensor network, right? In this scheme, every cluster, at every cluster change time, the cluster head broadcasts the following to its members, right? Hard threshold and soft threshold. What is this threshold? Why we need this Teen algorithm? See, the reason is every time whenever you think about wireless sensor networks, the first thing is lifetime of the network. That is in turn dependent on lifetime of each and every sensor node. That is again dependent on the battery. So that is, whatever the concept you are discussing is energy efficient. Right? Suppose if you go abroad for education, everything is money oriented. Anything you want to do, you have to be conscious about money. because there if you go US, everything you have to spend in terms of dollars, right? So you have to think very carefully. Everything will be linked with money. So wireless sensor networks, every time you talk about battery, energy efficient. So how to use the energy efficiently? So here, what people thought is cluster. This first phase is cluster formation, right? Here, this is cluster formation, right? Then, so here, when to change the cluster, right? Cluster change time has started, and by this time cluster formation has been done, right? Here, the thing is, if you consider some networks, right? Okay, we'll go through it. Hard threshold. There are two thresholds, right? In every cluster change time, the cluster broadcasts the following to its members. Other parameters are there in addition to them. Hard threshold. This is threshold value for the sensor attribute, right? And it is the attribute value of the attribute beyond which the node sensing this value must switch on its transmitter and report to its cluster head. Right, soft threshold. This is a small change in the value of the sensor attribute which triggers a node to switch on its transmitter and transmit once the hard threshold has been crossed. In team, nodes thereby make it appropriate for real-time applications. Right. So what is happening here? Yeah. Yes. Yeah. So the first time a parameter from the attribute set reaches its hard threshold value, the node switches on a transmitter and sends sensor data. Right? So what is happening, why we are using these thresholds? The thing is, a sensor node is sensing the environment continuously. Should it send all the sensitive values continuously and waste its energy in the form of communication, switching on the antenna and then sending continuously? No, that is not a wise thing, right? So the thing is, sensor will switch on its transducer, it is sensing continuously. Whenever the sensed attribute value is crossing the hard threshold, then only it will switch on the antenna, that is transmitter, and sends it. Once it is sent, again it is switched off. Then again, at what time again it is switched on? There is another soft threshold. If the sensitive value is varying means may increase or decrease by certain threshold, then again it is going to inform. It is like, let us say, the temperature application. Hard threshold is 35 degrees centigrade, 35 degrees Celsius, right? Degrees centigrade, right? So what is the thing is, once you deploy the sensor node for the application for weather monitoring, in the morning we have switched on the network. Morning the temperature was only 20, right? And then gradually increasing, right? At 7 it is 25, at 9 it is 30, at 10 it has become 35. So till such time it is only sensing but not sending. Once it is touching 35 degrees, it is switching on the antenna and sending the report to the weather department. the temperature in this area. Like one sensor node will send a value. Of course, as we have discussed, there is a concept called data aggregation. Not all the sensor